Let's talk a little bit about solving radical equations. So a radical equation is just an equation where the variable is inside a radical. And in general, our first goal when we're solving a radical equation, we want to try to get the variable outside of that radical. The way we typically do this is by raising both sides of the equation to the same power. This is really making use of a property that says essentially if x is equal to y, then x to the n is equal to y to the n. And so I raise both sides of the equation to the same power. Here I raise both sides to the nth power, and that typically is going to work. These steps are sort of the steps you can think of as you're solving one of these. In order to raise both sides to a power, it's important first that we isolate one of the radicals on one side of the equation. So we should just have a radical by itself on one side of the equation. Obviously there will be something in the radical, but there shouldn't be anything outside the radical. Then I raise both sides to the same power as the index. If it's a square root, you square. If it's a cube root, you cube. Then we're going to solve the resulting equation. Now, we're not going to get quite this complicated, but if you do that equation, if you still have the variable in a radical after doing steps 1 and 2, you have to repeat steps 1 and 2 until there are no radicals left. And then the next step, it's essential that you check all solutions. This is not optional. This method can lead to some things that are sometimes called extraneous solutions, which they're really not solutions at all. And we'll see that as we go through some of these problems here. So this first example, solve the square root of 2x minus 3 equals 7. Notice I already have the square root is by itself on one side of the equation, so I don't really have to worry about step 1 here. Then I'm going to note what the index is. There's no index written here, so that really is, there's really a little 2 there. So what I'm going to do then is I'm going to raise both sides to the second power. So we've got the square root of 2x minus 3. I'm going to square that, and that's going to be 7 squared. The idea, of course, then, if I have a square root squared, that essentially cancels out, right? They undo each other. So the radical goes away. 7 squared is 49. And now I can solve this equation that I'm left with. I just have x to the first power, so I can get x by itself. I'll add 3 to both sides. That gives me 2x equals 52. And then I'm going to divide both sides by 2. And if I do that, I get x equals 26. I need to check. So I'm going to plug in 26 instead of x. Does that work? Yes, I get the square root of 49 equals 7. So this solution x equals 26 is a valid solution. Okay, now in part B, to solve this equation, a couple things are different. First of all, it's a cube root, so that means I'm going to have to take a third power. Second, this cube root is not by itself. This plus 4 is going to mess things up. So I'm going to get rid of that plus 4 at the beginning. I'm going to subtract 4 from both sides. Okay, and now I can take both sides to the third power. When I cube a cube root, as long as the power and the index are the same, that cancels out. And so I get x equals 10. I can check this. The cube root of x minus 2, so 10 minus 2 plus 4, is that equal to 6? And the cube root of 8, remember I think what times what times what equals 8. So that would be 2. And 2 plus 4 is equal to 6. So x equals 10 is valid. All right, part C here. I've got a square root again. So I'm going to square both sides, but not yet. I'm going to have to get rid of this plus 5. Just to show you once, what happens if I don't do that? I could square right now, but the whole side has to get squared. And what I would have to do here then, to really do this correctly, I would need to write that down twice. And now do FOIL. The problem is when I do FOIL, when I do first here, that's going to be okay. The square root times the square root will cancel out and I'll get rid of the square root. But when I do outer and inner, I'm going to get a square root back. And so I'm not going to get rid of the square root. So you can't do the power too quickly. You've got to wait until you get the radical isolated. So what I've got to do first here is get rid of that plus 5. So I subtract 5 from both sides, and that's going to give me the square root of x minus 3 equals x minus 5, and then I'm going to square both sides. The left-hand side is easy. The squaring a square root, that just goes away. The right-hand side, I have to do that little thing I talked about earlier. I've got to write this set of parentheses next to itself. What's not too bad is this FOIL, I don't get any square roots. X times x is x squared. Outer, I get negative 5x. Inner, let me redo that. Inner, I get another negative 5x, and last, negative times negative is positive 25. Now, I need to, again, solve the equation. The radicals have gone away. Notice I've got an x squared here. Since I've got an x squared, that means this is a quadratic equation, and it doesn't look like the x squared is going to drop out anywhere. To solve a quadratic equation, I have to try to get the whole thing equal to 0, and then hopefully I can factor. So I'm going to clean up the right-hand side. I'll combine those like terms. And now I want to get everything, I guess I'm going to get it on the right-hand side because I like the x squared where it is. That means I'm going to have to get rid of the x. I'm going to subtract x because I'm getting that equal to 0, right? And I'm going to add 3. And I'm just going to do both of those at the same time. And so I get 0, that was my point. I get negative 11x plus 28. And now I try to factor that. So the x squared has to be x and x. Since it's positive 28, that means I need to have the same signs. So I need two numbers that are going to multiply together to give me that 28. And then they're going to be the same signs to give me 11. So I think 4 and 7, they'll both have to be minus for this to work. Remember how this works then? I've got these two factors multiplied to equal 0. I just set each factor equal to 0. So x minus 4 equals 0, or x minus 7 equals 0. I'll add 4 to, equals 0. I add 4 to both sides. I add 7 to both sides. So I get that x equals 4 or x equals 7. But I need to check. So first I'm going to check x equals 4. So the square root of 4 minus 3 plus 5, is that equal to x, which we're saying is 4? So the square root of 1 plus 5, is that equal to 4? Square root of 1 is 1. 1 plus 5 is not equal to 4. So x equals 4 did not check. I can't include that as a solution then. I try x equals 7. The square root of 7 minus 3 plus 5, is that equal to x, which I'm saying is 7? So square root of 4 plus 5, is that equal to 7? 2 plus 5 is equal to 7, so that checks. So 7 is a valid solution, but 4 is not. Okay, one more problem here, and then I'm going to talk about this extraneous solution thing a little bit again. Here I'm going to try to get the square root by itself. I could move the x over, but this negative in front of the square root bothers me a little bit. I think it would look cleaner if I didn't have that. So I would probably take this and move the square root to the other side first. So I'm going to say plus the square root of 17 minus 4x plus the square root of 17 minus 4x. So I'm left with x equals 5 plus the square root of 17 minus 4x. Now I have to get this radical by itself. I'm going to move the 5. So I'm going to subtract 5 from both sides. So I'm going to get x minus 5 equals the square root of 17 minus 4x. Since it's a square root, I'm going to square both sides. On the left, I'm going to have to do that as two sets of parentheses. On the right, it's just a square root squared, so that goes away. I do FOIL over here. So minus 5x minus 5x. I guess that's the same one we just did on the other page. Like the last problem, this is squared. So I'm going to combine like terms. And now I'm going to get the thing equal to 0. So I'm going to get rid of 17. And I'm going to get rid of the 4x. So I'm going to get x squared minus 6x plus 8 equals 0. It's plus, so they're going to be the same signs. X and x gives me x squared. So it's got to either be 1 and 8 or 4 and 2. It looks like the 4 and 2 would work. I'm going to get minus 2 and minus 4. So I'll set both of those equal to 0. So I get that x is equal to 2 or x is equal to 4, but I have to check. So if I check x equals 2, I plug 2 in for x up here. So x minus the square root of 17 minus 4x is supposed to be 5. 17 minus 8. So 2 did not check. And then I try 4. So I plug 4 in for x, so I get x, 4, minus the square root. 17 minus 4x, 4 times 4. That should be equal to 5. 17 minus 16. So square root of 1. Oops. No, in this case, neither of the solutions works, which means I have no solution. Now, it's possible, if you end up with a quadratic equation, the one we did on the last page, part C, had two solutions, and one of them checked and one of them didn't. This equation had two solutions and neither of them checked. It's possible that both of these would have checked and you would have had two solutions. You really don't know until you start to check. Why do I get extraneous solutions? There's a couple ways of understanding this. First of all, we defined the radical symbol to mean the positive square root in this case. Cube roots can be negative, but even roots always give me positive numbers. And so when I have the square root of 9, that just becomes 3. If I could let the square root of 9 be negative 3, then this would be 2 minus negative 3, and that would be 5. Or here, 4 minus negative 1 would be 5. So it's really a problem that we had this square root symbol at the beginning, and whoever wrote the equation intended that to be a square root symbol, which means the positive root. When I square both sides, I sort of lose that information. And that's what I'm looking at here. If I have the equation x equals 3 and I talk about the solution set, what I'm saying is what numbers could I put in for x to make this equation true? What could I substitute for x? We don't even really think of this, but my solution set, the set would just contain the number 3. However, in the equation x squared equals 9, which is what I get if I square both sides of this equation, now notice that my solution set has expanded. Negative 3 works for x, positive 3 also works for x. So when I squared both sides, I introduced an extra solution that wasn't there before. And you run the risk of doing that anytime you square both sides. It turns out with this checking business, you really only have to check if you start with an even root and then take an even power. So if I look back to the first page, no, not the first page, the second page, the other first page, all right. So this part B, since I took the third power of both sides and it was a cube root at the beginning, I really didn't have to do this check. But sometimes it's easier to just think, okay, if I'm doing a radical equation, I have to check my solutions.